viewers, now I discuss another very important theorem in measure. Let's watch this theorem in this video without skipping. Let delta be an open interval containing E. E is bounded set, already we know, and then M upper star E, that is exterior measure of E, plus M lower star delta slash E, that is interior measure of delta slash E, is equal to M delta. How to prove this inequality? This is very important, and the viewer who are watching this video first time, they subscribe the channel and press the bell icon to get all the notification and latest update of my videos. Now we are going to the part of proof. If we could taking this condition that let delta be given in advance, if we are taking, and then we find a closed set, if we consider a closed set F, this F is the subset of delta slash E. So if we are taking delta slash E containing a closed set F, and with this condition like this, measure of E is greater than interior measure of, that is measure M lower star del slash E minus epsilon, and now the set G is equal to delta slash F, which is bounded open set and containing E. As F is closed, so delta minus F, that is delta slash F, that means delta minus F is open set containing E, such that M upper star, that is M superscript star of E, is less than M of G. Exterior measure of E is less than measure of G, and this measure of G certainly equals to measure of delta minus F, that is measure of delta minus measure of F, and certainly this will be less than measure of F minus measure of M lower star delta minus E, delta slash E plus epsilon, if we are taking in this manner. As we say, MF is greater than M lower star delta slash E minus epsilon. Using this inequality, in earlier cases we are putting this value, so we are getting M delta minus M lower star delta minus E plus epsilon, and epsilon, as epsilon greater than 0 is arbitrary, so we have M upper star E plus M lower star delta slash E is less than M of delta, taking it equation number 1. And again we are assuming epsilon greater than 0 is arbitrary, and we find a bounded open set G0 such that G0 is the superset of E with M of G0 is less than M upper star E plus epsilon by 3. Now let us write delta is equal to open interval of capital AB, and choosing the open interval of small ab is included in delta such that capital A is less than small a, less than A plus epsilon by 3, and B minus epsilon by 3 less than small b less than capital B. Now putting delta G is equal to delta intersection G0 union capital A interval of capital A small a with union interval of small b capital B, and so G is a bounded open set containing E having the property M of G is less than M upper star of E plus epsilon, and further delta minus G, that is delta by delta slash G, is equal to closed interval of AB intersection of G star, that is G dash. G dash is the complement of G, that is G dash, and hence G by delta by G is closed, and since F is included delta minus E, we find M lower star delta by E is greater than MF is equal to M delta minus M of G greater than M delta minus M upper star E minus epsilon. As delta greater than G is arbitrary, delta greater than 0 is arbitrary, we have M lower star delta by E is greater than M delta minus M of upper star E, that is M lower star E plus M lower star delta M of and therefore m upper star of E plus m lower star of delta slash E, that is delta minus E, is greater than m of delta, taking it equation number 2. And now from equation 1 we have m upper star E plus m lower star delta minus E is less than equals to m delta, and taking equation 2, m upper star E plus m lower star delta minus E is greater than equals to delta. So from 1 and 2 we combinedly written as m upper star E plus m lower star delta by E or delta minus E is equal to m of delta. Now finally through our desired result, we end our discussion today. If you like this video, like it, share it, and always subscribe the channel. Thanks for watching.